Very good morning, all of you. I hope I'm audible to you. Very,
Yes,
very
you are
good
audible.
afternoon. Very, very good afternoon in the fourth day of our FDP, that is 5-day international FDP program on effect of generative AI in modern research and industry, organized by Sister Nivedita University, West Bengal. India by the Department of Computer Science. So, before starting the session today, I would like to welcome our guest of honor for fourth day, that is Dr. Professor Shoikat Maiti. Professor Shoikat Maiti is currently working as professor in Computer Science Department of Sister Nivedita University, Newtown. He has a total of 23 years of experience. He has obtained BTech from Computer Science and Engineering from Kolani University and completed his MTech in Computer Science and Technology from Calcutta University. He pursued his PhD in Computer Science of Technology from Indian Institute of Engineering, Science and Technology, that is IIEST, or formerly known as Shibpur Besu. His main area of research has been practice in software engineering and artificial intelligence. He is working in primarily domain of networking and multimedia soft computing, image processing techniques, and all. So I completely believe that he is having and more expertise in other areas also. So I would like to request you, sir, that if you share kind your words to initiate the program for today, kindly accept the honor. It is over to you, sir.
Thank you so much, Dr. Datta, for a very warm welcome. Very good afternoon to all my participants, all my esteemed speakers, those who are present in this FDP. It was a fantastic session, and a galaxy of speakers are there in this particular FDP, starting from India to abroad. Some of the researchers who are extremely doing well in the sense of generative AI, in the line of generative AI. Some of the faculty members, those who are working in the niche area of generative AI, and as nowadays, generative AI has become not a buzzword nowadays. It has become a kind of technology to the mankind. And nowadays, generative AI is playing a vital role for in all the areas. So all my esteemed speakers, my participants, it's a great enthusiasm and anticipation that I will extend my warm welcome to all of you, each of you, for the faculty development program on the generative AI at Sister Nivedita University. Definitely your participation and event underscores your commitment, exploring the cutting edge solution, the technologies, the advancement of the frontiers of the knowledge in the field of artificial intelligence. And of course, the generative AI, which stands in the forefront and in the innovation part, offering the unprecedented opportunities for to create, innovate, and aspire all the young minds, as well as the faculties, the developers, and the students, the educators, and the researchers. For the engagement of the program is a kind of instrumental for shaping the future landscape and AI. Of course, the this program will have curated for enriching the lineup of the sessions for the workshops and the discussions led by the distinguished experts and of course the practitioners in this particular field. So exploring the latest advancement in the generative model is also delving to the practical applications, ethical considerations. Of course, the session promotes to ignite the curiosity of each and every faculty members, as well as the professors, the learners, the listeners, the foster collaboration and the spark of transformative ideas through the very common question answer sessions. I also encourage to activate the participate or ask the questions, because we have got two fantastic host people, those who are there with us. They are expert in this particular session, how to handle the session very nicely and leverage the platform to discipline for all the understanding of the generative AI, of course, towards the harness of the immense potential of the positive impact. As we embark in this journey of exploration and discovering together, let us embrace the spirit of inquiry, innovation, catalyze the unlocking new insights, groundbreaking advancements, the realm of Gen AI. And of course, I extend my heartfelt welcome to all the speakers and the participants of the faculty development program of generative AI. Of course, your presence and contributions are invaluable, and I'm confident that together we'll make this program more resounding of success. Let's put our footsteps, let's put our footprints in such a way so that in future we can go for a very nice and collaborative work together. So with this, I'm concluding my remarks. Thank you once again for joining this wonderful FDP. And I would like to thank all my esteemed speakers, those who have given their valuable time to train us, to having a great lesson of learns or the lesson of expertise, which we are really looking for. Thank you so much, sir. Thank you so much, professors, for giving your valuable time. And I hope that you will definitely enjoy each and every session of this particular FDP, and let's make it a grand success for all the part. Thank you so much.
Thank you, sir. Always you are very motivational speech every time you give, and personally working with you, it is, I must say, you are an inspiration for all of us equally. So thank you, sir, once again. So I'm just starting with today's session. Our esteemed speaker for today is Dr. Soumya Sen. Sir has already joined. Sir, I have made you co-host so you can unmute yourself. So before starting the session, I would like to introduce our speaker with you today. Dr. Soumya Sen is our assistant professor in AK School of Information Technology, also teacher in charge in the Department of first year to fourth year BTech students under University of Calcutta. Dr. Sen has joined AK Chaudhary School of Information Technology in March 2009. He was awarded with PhD degree in 2016 from the Department of Computer Science and Engineering, University of Calcutta. Before joining AK Chaudhary School of Information Technology, Dr. Sen also worked in IBM Private Limited and RS Software. His industrial expertise includes ERP and data house. Currently, his research area interests are data warehouse, OLAP tool, big data, data analytics, service engineering, distributed database, blockchain, etc. Dr. Sen has published around 120 research papers in peer-reviewed journals and international conferences. He has 3 patents registered in USA, Japan, and South Korea. He has also published 2 books with Springer in form of Springer by Brief, and also registered 2 copyright from Government of India. His research collaborations include institutes like CA Foscari University, Italy, Toyo University, Japan, Era Institute of Canterbury, New Zealand, California State University, USA, Eastern National University, etc. Dr. Sen is a reviewer of many international journals and PC member of and reviewer of many international conferences across the world. He has very good research collaboration. He has acted as a session chair of several international conferences. His total citation is more than 1500 and H-index is 20. Dr. Sen is a member of IEEE ACM and fellow institution, and that is IETE. So I welcome you, sir. Please start the session. And now I have handing or stop the share. So you can share your screen and you can start the session. Thank you.
Thank you, Dr. Dotto, for my brief introduction. Hope I am audible.
Yes, sir, you are audible.
Okay. I think, is it important to switch on the video for the bandwidth?
No, sir, I can understand. I myself have turned off the video, so
No,
definitely you can
actually, in
continue
order
with
to
this
avoid
one.
the bandwidth issue, I just want to.
Yes, sir. Yes, sir. Sure.
Thank you. Just to give me a moment, I'm going to share the document. Hope my document is shared and everyone can view it. Whether my document has been shared, can everyone view it?
Sir, it is not coming in slideshow mode.
Okay, just give me a moment.
Yes, yes.
Is it visible now?
Sir, the slide is visible, but not in a slideshow mode.
But
Maybe you have to reshare that.
Okay, that could be a problem. Okay.
Yes, yes.
I think right now it is being shared.
Yes, sir, it is coming.
Okay.
Yes, sir.
Okay, thank you. Thank you for all the participants for joining the session. And as it is the fourth day of this particular FDP, I hope that you have gathered certain knowledge about this particular topic. And so due to that reason, I may skip some of the portion of my slide because this particular slide covered many things, but I believe that the beginning portion is not that important because you must have studied these things during this particular 3-4 days. Okay, but I think a problem I cannot change that. But please wait. I mean, there is a little bit problem in sharing the full screen mode. Just please give me a time.
Sure, sure.
Okay, whether my slide has been changed.
Yes, yes, it is changing, sir.
Okay, okay. So at the beginning, I have started the slide with AI and then machine learning. I think these things are known to all of you. Just I want to show this particular picture to all of you. Hopefully, this is also known to everyone that for the traditional programming, what we do, we work with program. In a program, we give certain input data and then we are generating certain
ওদের
output.
একটা কি মিটিং চলছে মনে হয়
In the
ওদের
case of
meeting-টা।
machine learning,
হ্যাঁ,
what happens?
ওইসব
We
চলছে।
feed different data into our program. We know
না,
what is
নেই
the
তো,
desirable output,
নির্বাণদার ঘরে
and
তো
we
ওখানে
try to.
সারাদিন ঢুকলাম, দেখলাম ওইটাতেই কানেক্টেড।
Madam, can you please mute yourself?
Sir, all are
Okay.
muted.
Okay. So in the case of machine learning, what we do, we are trying to find out the suitable program or the suitable model for which we can get the desired output. So this is about the machine learning. Now, when we are coming to generative AI, what is the thing that we want to focus? In the case of generative AI, our main target is to generate some new content. And this is the very special feature of the generative AI. In the traditional AI, we not actually focusing on generate something new. Rather, what we do, what we already have in our system, from that we give some outcome, some result. But the generative AI has the capability to generate some new content on its own, and that makes it so much special. And all of us are using ChatGPT, and ChatGPT is the most widely used example or most widely used tool for using the generative AI applications. And from that, we know that what we could do, we could ask ChatGPT to even write a poem, and we need to make sure, rather ChatGPT makes sure the suppose I'm asking to write even a romantic poem, but that romantic poem is going to be different for two different users. Okay, so it has the capability not only to generate the new thing but also have the capability to differentiate among them. So in the case of chat gpt or the generative AI tool, we need to use different advanced algorithms. There are so many algorithms because actually this particular topic has, the generative AI has so many things to say. So I thanks the organizer for making it a 5 days FDP so that you can come about different aspect. In my title slide, you have must have found that I have focused majorly on the RAG and vector database. There are other issues actually how this subject has been evolved. The subject has been evolved with the different machine learning, deep learning algorithms. One of them is GAN. GAN is there for past few years. Some of you have already worked with GAN, and the GAN is one of the major component that we use for the generative AI purpose. And for GAN, the full form is generative adversarial network. In I am not going to the depth of the machine learning or deep learning. Just in one line, what I like to say, in the case of generate, it has two components. One is generator, another one is discriminator. From the name itself, generator tries to generate some new output, and discriminator, on the other hand, try to evaluate their authenticity and try to discriminate among the different output that are being generated. And the training process that is we follow over here is called adversarial training. And for the components of the generative AI, we have different components such as generative AI algorithms. We need to use neural network. I think most of you have the idea of a neural network. You might have studied or you might have worked in this area. We need to use deep learning. This GAN, VAE, these are the different algorithms that we are used from the deep learning perspective. And the last component that I mentioned
Please stay on in the link, please. Maybe there is some problem in the screen sharing. Shomo sir, am I audible to you? Your screen share has stopped. Kindly, if you share your screen once again, and you are not audible too.
Am I audible now?
Yes, sir, you are audible, and your
Yeah,
screen
actually,
share
probably you
screen is
muted
also
by
visible, sir.
somehow I have been muted. Okay. Okay,
Yes,
so
yes.
up to which slide I was audible to all of you?
The previous slide, it was just about to start.
Okay. Okay. The previous slide was about the different algorithms. So I'm not going there. So I'm coming to the application of LLM. So what I'm talking about that we use LLM for writing poem. We use LLM for different information retrieval. Whether if you have used any LLM or worked with some LLM application or vector database, you can find you can take your text and now feed them into the application such that you can retrieve the desirable information from the system. Okay, there are other case where we can explore this the use. We can use it for the sentiment analysis. Chatbot is a very common example because many of us have used chatbot. Over there we are also use this LLM model. Okay. Now for the LLM, the key, there are certain components that we use for LLM. One of the very important thing is that we are using embedding layer, or this embedding is a part of this vector database that I shall discuss in a depth. What is embedding? I want to give this concept at the beginning so that that will be easy for you. One of the very important thing is that while we are using the traditional database, what we do? We use the traditional database for retrieving the information as it is given over there. Over there we actually search for the particular data. For example, if it is an account related information, suppose the banking database, so if we are asking the account number, we will get the particular account number. But in the case of LLM, when we are using the applications of LLM, it's not we are using a particular thing. Rather, as the content is to be generated, it is very important to find it out that what is going to be the closely matched content, not the exact one. Okay, this is the very important thing that everyone should try to understand. This is the difference. In the case of traditional database, we look for the actual data, but in the case of LLM or generative AI application, we are looking for the data which is very similar or close to the application. The example could be, often we used to listen songs in the YouTube, and you can find out the YouTube is coming up with lot of suggestions. Now regarding, if you kindly carefully look at the suggestion, the what will happen, you can find some of the songs have been suggested which is close to the genre of the song that you are listening. Sometime you can find it is the song, maybe some other song by the particular singer. Okay, or maybe the song at that time, maybe I am listening to a song that has been from 1970, 1980. So you can find some song will be from there. So for one particular content, it is doing the analysis on several parameters. So here the beauty of this particular concept is that you need to figure out the different relevant features of the particular application, and based on that particular feature you need to store the data in such a way such that this data could be retrieved based on this identity with different type of features. How these are being represented, that I shall going to explain over the time. And now one of the very important, another important thing, as this searching process is there and based on the vector, lot of queries, lot of results could come. And now for that, what is important, the searching require lot of data retrieval. And for that, feed forward layers are used, which is the part of the artificial neural network. And there are hidden layer, you are aware of that. And the number of hidden layer increased, we can actually increase the search space. And with the increased search space, we can retrieve more amount of data. And now whether that will be relevant or not relevant, that is another issue, because again I shall discuss about that LLM are not often performed quite well. But okay, but over the time we will improve and we will switch to the RAG. And there are other layers of neural network which we also use. One layer is called recurrent layer, where we try to find out the relationship between the words in a sentence. And in the attention mechanism is another concept where we want to find the context of a particular word in the particular data chunk, or chunk is, as I am not introduced, you can think in a particular paragraph how it is related. So these are the different components that we use in the case of LLM. Now, for the LLM, how it works, for that, I am not going to details of the LLM because my major focus of this talk is RAG and vector database. So I'm trying to jump over there quickly. Now in LLM, it is called transformer model. And maybe many of you are aware about the transformer model. In transformer model, we take a sequence of input and we are producing sequence of output. Obviously, that is in a meaningful way. And for that, what is very much important, we need to do lot of training. But over the time, as the system has been matured a lot and sometimes we skip this training portion also because some LLM are already in use and they have been trained. And for some certain application, we are go for zero shot, few shot training so that with minimum amount of training and no training, also the LLM can give desirable result. Now for LLM, the working principle, the first thing that I have all mentioned, that is the training. We need to train our system. Next portion is the fine tuning. Now regarding fine tuning, there are many aspects. One thing is that how we are generating the vector database, with how many features we are generating, because people can search a particular any particular content in website with keeping in mind different issues. For example, as a researcher, when we find a document, we want more depth. But the common people, when search a same topic, they want to see some popular talk type of thing. That's mean that things have been easily explained. But when we are looking from as a researcher perspective, we will not be satisfied by getting something which has been easily explained. Rather, we want to check that whether it contains the different research material, whether the mathematical properties have been defined or not. So for different user, different type of requirement is there. So customization is already there. You know that in Google, what we like, we prefer, accordingly the search result comes. So accordingly, your LLM also need to be fine-tuned to match your requirement. And the next portion is the prompt tuning. You must have heard this particular term because while we are working with LLM, that's mean the people who are actually doing the trying to make LLM better, they need to make sure that the prompt, the interaction is being taken place to the prompt, which is also known as prompt engineering. So now how the prompt can be tuned further, how the further tuning is required, because one LLM application is not for all the purpose. Maybe ChatGPT is a very powerful tool, but while we are using for certain purpose, some application we build for some certain purpose. So for over there, if you are going to ask anything, that system will not be able to give the answer. But what happens, they often, LLM has a tendency to give wrong answer, which is called hallucination. I am going to explain it over in the next slide. But so due to that reason, we need to make sure that the prompt, while we are writing the prompt or performing the prompt engineering, we are making sure that my prompts are being upgraded such a way so that we are getting the desired result. Now, LLM has certain problems. What are the problems? First problem, what is called hallucination. Hallucination means even LLM is not getting the desired result, it will come up with any result. And often that are wrong. Very carefully listen. Often they are wrong. I have an experience to work with a team. They are actually developing this generative AI tool. And for them, what happened? In that particular website, I searched with the healthy food. Now, those persons, the team who are actually working with this LLM tool, they are US based. Now, while I am searching for the healthy food, I am getting the address or different stall which are located in the particular city of which city I forgot of USA. Now, think for me, I am searching my data from Kolkata, and if what it will going to benefit me by getting the different shop address or shop description which is from a particular city of USA. So that is a sorts of hallucination. Now, second thing is security. Security is that while it is fetching data from the different sources, it does not look into whether these data are from a which side. Maybe some of the sites are for secure purpose of the proprietary copyright issue, but it does not check this thing. So due to that reason, the people who are developing these LLM tools, they are in trouble because they may face some data which is not correct as per law. And the next point is the bias. The bias is already I explained that as they have trained their model with the data from a particular city of USA, the system is showing data from that particular city. So this is a type of biasness, and these are the some problems that we get in the case of LLM. So over the time, the new concept has been evolved, which is came as retrieval augmented generation, popularly known as RAG, that try to eliminate some of these problems. Actually, the LLM part has the generation part was in LLM. In with RAG, we have incorporated one more step that is called retrieval. And this for this retrieval, actually, what happened? The people who are working with this RAG, they need to have some expert who are going to find out how to search the authenticated sources. For example, as a researcher, we know if we want to search some research content, where we search? We search from the IEEE, Elsevier, Springer journal, because we know that these are the good content. Now that is the knowledge we have retrieved over the time. But while you are telling your student to search the document, they will search the document from some popular pages which are appearing at the beginning in the Google. Okay, so they are not aware how to search the good content. So now this retrieval also requires some expertise so that the system can verify that the source from which it is retrieving the data, they are correct, they are authenticated. So this RAG is going to ensure this retrieval part in a better way and have the advantages over LLM. Now, in this particular picture, you can find that in the right hand side, what I mentioned, that LLM pass actually work with the generation. With that, the retrieval part that we are incorporating over here, for the retrieval part, we also need to do prompt engineering to find out the documents which are correct. As well as what we do, we are storing the data in the form of vector database where the concept of embedding is required. And from that, we are finding which are similar in nature. Now, from that particular portion, once we are finding out what are the similar content in nature, now it is going to the content to find out which is matching best. So in this way, the retrieval augmented generation process is making the generative AI more enriched compared to the LLM. Now, in this particular picture, you can find it out that how this actually works. We have a lot of documents. With these documents, we train our model. Now, while we are training our model, we are using some embedding model. This embedding model is storing the data in the form of vector database. Okay. And now we are telling it as a vector stored, as well as we have the vector indexing also. Okay. But vector indexing, I shall not describe here due to the lack of time, but it's a very interesting one. And there are certain methodology. I shall just mention the name of some of the strategy that you can explore yourself. And now, while the people are making, the user of the generative AI tools are making the query, now from the query, the prompts are being generated. Now from this prompt, the searching is taken from the vector store that identify the identical feature. Okay, which is very important here for this particular searching methodology is called approximate nearest neighbor search, because what I told, we are not looking for the exact content, because the exact content not always we are looking for. If you are getting exact content, that is fine, but it is also important that nearby content, close content are very much important. And this approximate neighboring search is nearest neighbor search is going to make sure that you are getting the document which you are looking for. And finally, using the LLM, you are getting the actual content and your result is being generated, and that we are viewing as output. So this is the concept of the RAG. Okay. Now, regarding these two, okay. Now, regarding this, we need to understand two concepts. One is the similarity, another is the relevance. Okay. Now, similarity means that we are getting word by word matching or this type of thing. But while we are searching in this level, we are not actually looking for the exact thing, because our target is to generate something new content. So due to that reason, relevance came a very important role. Instead of going for the exact matching, we are going for the relevancy. And this relevancy, how we are going to find out this relevancy? We are exploring this relevancy in terms of certain features. So while we are doing this embedding, vector embedding, we are doing this vector embedding considering certain features. Okay, so it's very important that what are the different features that are relevant in that context, and in terms of this relevant context, we will find out the desirable thing. Okay. Okay, till this point, if anyone has any query, you may ask. Dr. Datta, you may unmute
Yes,
the
sir,
audience.
sir, you continue. Already I have given the message. If any of the participants have any query, they will put in the chat box. I
Okay.
will see it.
Okay, thank you.
Or you can see from your end also.
Okay, thank you.
So
Thank
you
you.
can please
Okay.
continue.
Okay, I'm content. Thank you. Okay, now while we are going to work with RAG, what are the different strategies or what are the different things we should know? First thing that we should know is called chunking. What is this chunk? Chunk is that we are working with, suppose we are getting certain content. Now, in that content, maybe it's a web page or maybe you are uploading a PDF. Now, all the things are not required. For example, if you are looking into a research paper, in research paper, we have introduction, we have conclusion, related work, proposed methodology, like these things. Now, while we are searching a paper, sometime what we are looking for, we sometimes looking for that what are the different papers that particular research paper has discussed about or referred. So that could be one part of our query. Or it could be sometime we are looking for the different methodology that they have used in their application. So based on that, one particular document need to be broken into several parts, and the several parts have several objectives. Or the objective means as per the user query, different parts are required. So you also need to, while we are working with this RAG application, we need to divide our document into number of chunks. Okay, so this is the chunking strategy. Now the next question is coming, what should be the size of the chunk? Now regarding the size of the chunk, there is no particular theory, but I try to give you some idea. If your query is very much specific, small chunk is going to help you. Why? Because small chunk will able to contain the result that you want to check. But while we are searching as a researcher, our searching is not one particular thing, because one particular, for example, maybe I am searching regarding the research in RAG. Okay, now while I am searching research in RAG, there are several areas for which you can do work. You can work with the vector database, you can work with the knowledge graph, you can work with the deep learning algorithm, you can work with the ANN algorithm. So different things are there. So while you are searching as a researcher, if the size of the chunk is higher, you can actually take you to the multiple places. But while you are searching as a layman, the multiple option will create problem to you. So it depends on the application that what should be the size of the chunk for the particular domain or application with which you are working. Next thing is called the document hierarchies. Now regarding the document hierarchy, for one particular query document, there are several documents. Now how I am going to search this document? It is also a very cumbersome process. I am showing the picture. Now instead of searching one particular document, if it is being organized in a hierarchical format, it will be easy to search. Why? Because while we are working with, suppose, the research topic, maybe for this RAG, you are choosing the, for this generative AI, suppose you want to do the research in vector database. Okay, now for this vector database, from the multiple path, you can choose the path of vector database. Now from the vector database, there are also several things about the embedding, about the training, about the vector index. So the different chunks is going to represent different type of data. So while we are searching, it will be beneficiary and quick if the documents are being organized in a hierarchical format. And obviously this hierarchical format is somehow related, somehow not obviously related. So as I am talking about, and finally, while the desirable chunk you can retrieve by following this particular path. So in this way, the document hierarchy, the organization of document hierarchy is a very important issue while we are working with this particular methodology. Okay. Now, I am like to give you a example, because sometimes somehow it seems to be theoretical. Now, what I am like to say, you might be aware that in our country, in different states, the holidays are different. One beautiful example is if you look at the State Bank calendar. In State Bank calendar, you can find, if you have seen, that they mention that for every holiday, in what state those are applicable. Now, very carefully listen. Suppose I am also an employee of State Bank. Current, I am located at Kolkata, but I am searching from Mumbai about the holiday. Okay. So what will going to happen? Now, it can do the search of the holiday from all of the state if it is not properly trained. Again, you listen. Regarding this public holiday, if in every state of India, they have different public holiday throughout the year. Now, if you are searching, what will be the problem? You may not get the exact data. Why? Because it's important to mention that you are an employee from which particular state or you are located at what place. Based on that, the particular document will be fetched. Otherwise, the result that will get, that will be wrong. So your prompt engineering need to make sure that for which particular place that query is coming. Now this is challenging. Why? Because maybe you are currently sitting at Mumbai, but you are an employee from Kolkata. Okay, so if the system is going to sense that okay, he is currently at Mumbai and making the query from Mumbai, so fetch the data chunk which is for Maharashtra. Okay, now if the query it is not being mentioned that you are looking for the holiday in Kolkata or West Bengal, that particular thing will not be answered. So it's very important that while we are going to make the query retrieval, you need to make sure that how your prompt should be engineered to reflect the your exact requirement. So from which document you are going to check the or retrieve the data, that should be properly fine-tuned. So through fine-tuning, through prompt engineering, we need to make sure that the actual data is being accessed. Next thing is the knowledge graph. Regarding knowledge graph, I do not want to not going to discuss much because knowledge graph itself is a topic for which I can talk for 2 hours. But I just like to give the idea. Knowledge graph is a concept of graph database. Maybe some of you have studied Neo4j, which is a very good example of a very powerful graph database. Now, over there, what we do, the different edges, we need to incorporate the different logic. These logics are actually help to build the concept and relationship among the different nodes, and based on that we try to infer, because from knowledge graph we want to infer knowledge and we need to build this logic so that this knowledge could be generated. This is the way how knowledge graph works. It's a very simple way try to explain this thing, but I cannot focus much on knowledge graph because it's itself is a different topic. And another interesting thing is that query augmentation. That's mean while we are getting query, how I am going to understand that particular query. For example, this example is an interesting one, that someone is talking about fried chicken. Okay, maybe the information of fried chicken is you are searching, and in your database you have the information of chicken soup as well as of fried rice. Now, from ingredient perspective, fried chicken is close to chicken soup. But from the preparation perspective, fried chicken is close to fried rice. So you can understand, based on the context, you need to check which one is going to be more similar to the particular application. Okay. Similar way, another example I like to give, that while we are talking, maybe I am going to some sea beach and maybe I am waiting for my friend, my wife, whatever. And over the phone, I can tell, okay, I'm near the beach, or okay, I'm at the beach front. Okay, that seems to be similar. But while you are searching a room in a hotel, near the beach and beach front are different. Beach front means it implies that you are looking for a room where from you can directly view the sea. But near the beach does not actually tell that thing. It could be you can have the beach view, you may not have the beach view, but you are close to the beach, that it actually reflects. So again, while we are doing this thing using the RAG, it's very important to understand the context of the question. Okay, so now these are the different basic concept that I try to give as idea. Now I am just opening the chat box to find out if there is any question. Is there any question?
Sir, there are so many questions in the chat. So one by one, I'm just
So
asking
better you ask me the
what
question.
are the Yeah, what are the applications of nature-inspired computing, nature-inspired technologies, and nature-inspired optimization algorithm to this topic for today?
Okay, nature is, look, actually today I am not discussing about the deep learning or ANN, but what I can say, I am focusing on the retrieval augmented generation and the vector database. Okay, now while you are going to work with this thing, there have the components like the embedding of vector. Now for embedding of vector, while we are searching the relevant features, you can apply this thing. Is it clear? Because while you are going to search the relevant content over there, you can apply these methods, because deep learning, the ANN, these things we are using. So similarly, you can use this thing, but I am not going to focus on that particular algorithm. The particular algorithm you need to learn or you need to study after understanding how the data are represented in the vector embedded format or in the vector database. And while you are searching, you can apply different things. The Kaku search, you can use the ant colony optimization, you can use. But I am not going to tell about that. I am going to tell about the representation of the data in the format of vector. Now, for as per the query is coming, while you are based on the query, you are going to retrieve the content. For that, you can apply this algorithm to search the data. Okay. Next question. Dr. Datta, is there any question?
Yes, sir. There are another few questions. How to select meaningful chunk by RAG?
Sorry, please repeat. Meaningful.
How to sir, am I audible? How to select meaningful chunks by RAG?
Meaningful chunk.
Yes.
Okay, I already mentioned. Look, meaningful chunk mean it depends on again on the context. For example, if I am suppose I am a student of school or college, while we are searching a particular content, we are not going to the depth of it. We must just looking into the definition. I am happy with that. Okay, so while I am looking with the definition, it does the chunk size should be small. But for the same content, while I am want to do research, I require the different avenues, because on a particular topic we can do the research on different thing. So for the people, while they are searching for the research purpose, you need to have the chunk size comparatively higher, because that is going to contain the different aspects of research. So in that case, the chunk size will be higher. Okay.
Yes, sir. Sir, maybe there are two more queries in your post today.
Okay. If your queries you ask me, I think that will make the thing easy for the audience. So please, if there is query, please you ask me. That will be easy for me.
Can generate AI model be used for data augmentation in machine learning?
Obviously, whatever the strategy we are using, we need to use machine learning, deep learning methodologies. Without using machine learning, deep learning, we cannot do these things, because whenever there is a searching, there is a finding of any documents, training the model, we are doing the same thing of the machine learning, and based on our requirement, we will go to the deep learning, because deep learning is required because we are going to work with huge amount of data. And regarding this, I can like to refer that ChatGPT has been trained with some million of parameters in ChatGPT 3.5, and in ChatGPT 4 it has been trained with 1.75 billion parameters. I am again repeating, 1.75 billion parameters with that ChatGPT has been trained. So you can understand that what level of deep learning model we need to use while we are searching the data, and after the searching the data, the content is being generated by the ChatGPT. So without learning ChatGPT, machine learning, deep learning in depth, you cannot work quite well in the for the generative AI. Okay, so if someone think that regarding what happened now for the students, they are listening to a term, sir, I want to work in this area. But if you really want to work a good work in generative AI, you must do study machine learning and deep learning at a very depth level. Then you can do a good work. Okay, Dr. Datto, is there any more question?
Yes, sir. There is another question. If I provide a prompt to generate an image of a food, any AI to rate this healthness, which parameters should AI consider? How can AI determine if the food is good or bad based on the image?
Okay. Now this for the your model need to be trained enough. Now, if it is a weakly trained, it may not identify the thing properly. But if it is being trained properly, it will able to find out what particular image it we have uploaded. Okay. Now, regarding the food also, there are a lot of things. For example, if the system can identify the nail polish, okay, so it can identify that it is the food of some woman. So if something is going to be found based on that, so it will be there show that foot of woman with the if there is a shoes are being shown. So along with the shoes or the type of the shoes, it will retrieve from the database and it is going to be shown. So for one particular image you are uploading, it will find out the feature. Now maybe the picture you have uploaded with some skin disease. So now it will try to find out similar picture having that particular skin disease. Okay. Again, some food the picture you are uploading maybe have some plaster. So it will come up with the picture of the plaster or some treatment for the broken leg. It will retrieve like that. Now, for that, it need to identify the image in terms of number of features. As it need to identify in terms of number of features, the normal methodology of storing the data will not work. We need to store the data in terms of number of parameters, number of features. Hence, the vector database is required. Okay. Okay, Dr. Dutt, so now I am not accepting any more question. I am continuing after certain time. I am going to accept the question.
Okay.
Okay. So now about the RAG over LLM, what benefit we are getting? One important thing is that it is more accurate because the system is such that it searches the data from authenticated document. Henceforth, we get accurate result. Transparency, because while we are using these RAG tools, to retrieve any data, any information, it also shows the different sources so that the people can check these sources if required. But LLM tools do not show the different sources where from it is retrieving the data. Okay. And more important, using RAG, we can customize our application. And I also work in this area. Suppose I'd like to give an example that our students are working. You are uploading certain question into the your RAG tool. Okay. Now, after question mean the examination question. Now, it will be very much useful for the student. They are talking about a particular content, or sorry, a particular topic. So maybe it is for the database questions you are uploading. You are talking about normalization. You are configuring your prompt in such a way that you are getting normalization. So it will able to find out the question with normalization. Now, here I like to make a very important thing. Maybe it just search the data where the normalization term is there. So it will not be able to find the data where the questions are given in the form of 1NF, 2NF, 3NF, because it is going to do the keyword based searching. Now, this keyword based searching could be updated further by telling that no, normalization along with that, these data can also be stored. Okay, so if your LLM model is weak, it will not able. So RAG model is weak, it will not able to find out the question with 1NF, 2NF, 3NF. But if you are trained your system, so it can also find the question with 1NF, 2NF, 3NF. Okay, even if your chunk size is larger, because for starting normalization we need to study functional dependency, it can also come up with the question of functional dependency. Now if chunk size is large, it might be possible that the question could be given that how functional dependency is related to the normalization. So it will come. Now from that it will also find out the question of functional dependency for the searching of normalization, because it has found a context where normalization can be related with functional dependency. So the question from functional dependency is also coming based on your searching. Okay. So this is the way the customization can be done. And now up to what context you want to do, that is also control you can put in your RAG. Now, some of the use cases that I like to discuss here, that suppose one multinational company want to export their good to different country. Now, for different country, you need to fill up different document. Okay, or even forget, the example is given. Suppose I want to visit USA, I want to visit UK, I want to visit Italy, I want to visit Argentina. Now, different countries has required different document for applying visa. Now, what we have to do, we need to go to the website and need to find out what documents are required for every country. Now you can customize your rack such that it can search from the website or the visa information from the respective country's website and come up with the data. This is the power of the rack tools. Is it clear that we do not need to search for every document? Rather, your rack tool able to retrieve the data as it is required. Okay. Similarly, right now the automatic form fill up is also possible because a lot of data that are being asked for the filling up the form, we do not need to go to the actual system. It can search the relevant content and from that it can automatically fill up the data. And another important thing is regarding the supply chain management. Maybe one product you want to export from one country to another country, maybe some portion it will go through ship, some portion it might go through flight, some portion it is go through road. For different transportation medium through different country, you have different rules and regulation. So your rack tool will enable you to find out this thing for every transportation, what contents are, what permissions are required, and the relevant document it can search, so accordingly you can prepare. So this is the powerful of the rack tool. And what example I gave, that for the student, they do not even need to search that what are the different question in different year for a particular content. If we train, because all my students already did this thing in their BTech project, where they can find out the question content wise from the previous year questions. Okay. And over there, we also use analytics to find out the relevancy of the question. That's mean the suggestion generator that we also work. So I'm giving an example that how we are using RAG, and for relevancy, we also use some machine learning technique to compute the relevancy. So that's mean at first you need to define the mechanism to search the data. And after that, you need to, you are using machine learning tools to find out the importance of them. Okay. Now, after the discussion on RAG, I am going to the vector database. Now, from the name vector, all of us have studied vector in our school level. A vector, what I am not going to the actual definition, it's a mathematical representation which is able to store multiple data at the same time. And this is something which we require for doing this feature engineering type of thing, because we are working with multiple features of one particular data or one particular application, whatever we say. And for that, what we need to do, whenever we are getting a particular data or information, we are actually looking into this in terms of the different feature it has, and the vector database is going to store that using these several features. And now how it works, you must have some content, maybe the different question papers what I'm talking about. You need to have some application through which we will interact. Now we are going to use the embedding model, through which this embedding model we are going to store the data in the form of the embedding model is generating vector embedding, and that vector embedding is being going to stored in the vector database. So while we are going to make some query to the system, my query will also follow the same methodology to generate a vector, and from there we are going to apply approximate nearest neighbor search so that we can generate the desired content. Okay. Now, what are the different steps that we are using for doing this thing? I already explained that using embedded model, we are creating the vector embedding, and over there we are creating certain index so that the document could be generated quickly. Now we are using this vector embedding within our vector database so that the data can be retrieved quickly. And finally, we are issuing applying query over there. From the query, based on the similar vector embedding, we are searching the result. Okay. And this process I have already described. And for these, there are different hashing mechanism, graph-based searching mechanism that you can explore. That will be very much useful to make our system better, because it depends on the application. Because in certain application, we will go for the hashing-based mechanism. For certain application, we will go for graph-based mechanism. If you are working with graph-based mechanism, it will be possible to generate the knowledge graph, and in this way we will make our system better over the time. Now, Again, I am giving another picture that from the vector database is there, querying is there, and the post processing. Now, this post processing, how it is helping? The post processing is helping because how can we make our searching better? We can use indexing, we can use hashing, we can use different machine learning, deep learning algorithm for the searching purpose to make our application even faster. And here I am mentioning some of the techniques that are being used. I have not discussed this thing. So if you want to work in this area of vector database, you can study this different methodology like LSH, HNSW, PQ that I have mentioned over here. Okay. And these things are fine. And based on that, we are going to do the post processing. And one more thing is that over the time, re-ranking can be applied because obviously that if while the people are searching the data over the time, the searching nature can change because suppose one example could be Lakshadweep. Lakshadweep was not very much popular as a tourist spot to us, but after that Maldives event, Lakshadweep got a popularity. So what happened? So for Lakshadweep, the query will increase, the query on hotel, the query on transportation, the query how to travel to Lakshadweep is increasing. So based on that, you need to reorganize, retrain your model to actually find out the current requirement or the current scenario. So again, there you can use different machine learning or deep learning models to make it faster, to make it efficient. Okay. Now, I am going to give an example that how we are going to use that vector database for doing this embedding purpose. Here, we are taking certain animals are being identified in time of three features: swimming, flying, and walking. And suppose we are ranking their features in terms of the values between 0 to 3. 3 mean expert, 0 mean poor or not applicable type of thing. For cat can walk smartly. So for cat, for walking feature, we are giving the value 3. Cat cannot fly, so it is getting 0. And cat can swim little bit, so it is getting 1. Similarly, we are taking the example of duck. For duck, what happened? Duck can swim, but is not very expert in swimming. So we are assigning 2. Duck can fly, so we are assigning value 2 over there. Duck can also walk. So we are again assigning value 2. So now for duck, we are storing in this type of thing. Another example we have taken, which is called mud skipper, which is a type of a fish which can also walk in the land. Okay, so due to that reason, it has been assigned swimming, it is expert, so it is getting 3. For fly, it is getting 0 as it cannot fly. For walking, it is getting 1. So in that way, it is getting, so in that way, we can storing the data in our system with different features, and the feature vectors able to represent the data not in terms of cat, duck, or mud skipper, rather in terms of the features. Okay, so this is the way how we create our vector database, and we can, as it is a 3-dimensional representation, so this 3-dimensional representation is shown over here. It could be any dimensional, multi-dimensional representation. So we can represent the multi-dimensional using the multi-dimensional representation. But the question will come that how we are going to search them. The searching will take place using different similarity measure technique. And what are these similarity measure techniques? We have different similarity measure techniques like cosine similarity, Euclidean distance, dot product, like that. For cosine similarity, while we are applying, we will get 1 if the vectors are very close to each other. We will get 0 if they are orthogonal to each other, and if it is -1, that means they are totally opposite. Similarly, for Euclidean distance, if the distance is 0 or close to 0, that means they are very much similar. If it is close to infinity, that means they are not similar. If it is a higher medium similarity, if it is more than 0 but less than infinity, something like that. And similarly, we can use dot product. In dot product ranges from -infinity to infinity. So my negative values representing the dissimilar thing, 0 represent orthogonal vectors, and positive values represent the similarity. Okay, now again I want to take some question, because as I have discussed about the basic features of the vector database. So Dr. Dotto, can you kindly tell me the questions? Dr. Datta, can you please tell me the questions?
So there is still no more question. You can continue, sir.
Okay. Okay. So now, while we are going to integrate this RAG with the vector database, what are the different issues that we consider? The first issue is that text chunking strategy, that how we are going to generate the text chunk. I already discussed about the size, and also among the size, you also need to make sure that how we are going to access this text chunk. It could be based on indexing, it could be based on hashing. So that things we need to define, understanding the particular business domain. And now the top K parameter. The top K parameter means that while we are storing the data in vector database in terms of different features, so what for a particular query, what particular features are important? I like to give an example. If we say SCM, now for software engineering perspective, we can say it is software configuration management. For the supply chain, and also it's called supply chain management. Now the people from the MBA domain, for SCM it is supply chain management, or the people who are the management area. And for the computer science related people, SCM means software configuration management. So it need to understand that what, based on what particular context we are going to search the data. Okay, and for that you need to identify that what are the number of parameters for which we are going to do the search. Okay, so that you need to identify dynamically that what is going to be the top K parameter based on which we are going to search the data. Then another important thing is that the data which we are training the model, whether that is become redundant and there is a repetitive, because some event took place today. Okay, now for that same event, tomorrow's newspaper, in all the newspaper, the same information will be given. Now, if we train the model with the same information, what will be the problem? There will be no variation. Rather, instead of train the model with the same data, you need to take the data from the different day, because for the same event, maybe the Russia-Ukraine war, it is changing, the different event is taking place. Maybe Russia has thrown a missile to Ukraine. Okay, and it has hit a school. Now, from every newspaper, if we take the same information, that is of no help. Rather, it seems to be the system that multiple hitting took place to multiple school, but it is not that. Hitting took place to one of the school, but as you are retrieving it for multiple sources, it seems like there is a multiple thing. So you may think that there is a 10 such incident took place. So you need to find it out that whether this is a repetition or not. If it is a repetition, you ignore, and using your domain expertise, you may choose a particular newspaper which gives the information in a better way, so that over there you need to use analytical model to find out or to check that which particular document we will take to train our model. And finally, the query understanding. So for the query understanding, this is very important, that concept of query augmentation that we have used, what I told earlier, that if you are asking as a tourist to book a room near the hotel and beachfront, has a very specific meaning, but while someone is standing there and telling giving instruction to his friend, hey, come to that particular spot, I am close to the beach or at the beachfront, these have the almost same meaning. Okay, so this understanding the context is very useful. Now, one important feature of vector database I am going to discuss, that is vector database is not transitive in nature. Okay, now this example is going to help you. For example, here there is a question regarding call drop. Now we can search the reason of use in a document which has the title understanding network congestion and call drop. That is fine. Now from that particular document, you can search for the congestion in the 5G network. Okay, so A to B, B to C you are visiting, but from C to A, this is not correct, because 5G network and drop call, these two are different issues. Okay, because all the document, because from the 5G network, what document we are looking for from the drop call, we may not get it, because that particular document may not actually discussing about the 5G call drop. But from the general way of call drop, we can go to 5G call. From 5G, you cannot come to general call drop. So this is important, that while you are trying to traverse a path, the reverse path is not true, as it is not transitive in nature. So now someone may ask that how we are doing these things. There are already the algorithms are available. You do not need to consider whatever the content I show you. you feed them in this general text embedding model. This general text embedding model, using cosine similarity, we will get this value, and from the value you can find it out that how this differs. Okay, so finally I am looking to a, with all these things, a deeper view where the documents are being organized in chunk. Now using embedding model, we are generating vector database that could have a different representation based on how, with how many features we want to store the data. Now from the vector database, through prompt engineering, the question will come. Now we go to the LLM to generate the model, and finally we will get the answer. So while we are working with this vector database, different type of vector database, what are the different performance metrics we should look? One important thing is that load latency. That's mean what amount of time we are taking to load the data in vector database, and from that we are taking time to generate the index. Next point is the recall. Recall means that the how much the results are relevant to the user. So that is called the recall. And of next point is the queries per second, that how many queries the system able to process while we are using vector database. And I am just going to give the name of the two of the benchmarking tools. One is vector db bench, another is the vector db benchmark. Both of these are open source, so if you want to compare them, the different vector database, you can use this benchmarking tool to evaluate the performance. But one thing is that generally using our normal system, we may not get that about difference, because you require almost a GPU for doing this thing, because vector database are trained with huge amount of data. With our simple laptop, we cannot do these things efficiently. So you will not be able to get the result, a better analysis, because our laptops are not suitable for doing this research. But for small things, small application, it will fine, because question set generation, because the question set we are generating for the last 10 year 20 years question, that is not huge. But while we are going to really original content, that the chat GPT what we expect, that require the GPU, and GPU not of the low power GPU, high power GPU required. Okay, so if you want to do serious work, you really need to learn how to use the cloud services. Using cloud services, you need to procure the service, and based on that, you can do the work. Okay, and for vector database, I am mentioning the name of some vector database like Pinecone is there, Atlas is there. I have mentioned one indexing vector index, that Llama index is going to support different type of vector database. These names I have given for your convenience for now learning the thing. And finally, I am like to tell that how we can use vector database for our organization. You need to get the different document that you are displaying in our website. The website, okay. Now all the documents should be taken into a common platform. Okay. Now from the common platform, you need to break them into different block, and over the time, this block we are going to do the embedding on that block. After that, once the embedding has been done, we need to generate the different vector index over there. So in that way, we are going to generate the indexing. Now, after the indexing have been generated, we need to go for the index-based query. And finally, with this, our system will be ready, where we can use vector database for different search purpose. I like to give some example that for a banking system, the chatbots are often very much disturbing. Not chatbot, the IVR, because you are asking a question, then press this, then you can do these things. But if the chatbot is being developed with the help of the RAG vector database, what will happen? You can do a particular searching, you can do a particular query, your chatbot will give you the query immediately. Rather, the chatbot will not ask the many intermediary questions. So efficiency of a system is dependent on, for a RAG or vector database, how quickly we can give the correct answer to the user. So for that, you require several training, and over the time, you can develop a system that will able to give the answer to the user efficiently. Okay, so this is all about my presentation. So now if you have any question, please ask.
Yes, sir. I have here two questions. If you want to modify anything in ChatGPT, is there any scope?
Look, ChatGPT is a particular product. Okay, now this is very important thing. it is a proprietary software. Now, for a proprietary software, how can we do the change? If they allow to access some portion of the chat GPT, then only you can do it. Rather, what you can do, that why you are going to chat GPT, that is their product. You build your own RAG. It is possible. It is not that difficult, because I told that my students, my BTech students have developed their RAG system. You need to, what you need to do, you need to use the vector database. Okay, you need to learn prompt engineering. There are a lot of tutorials are available. Now you use them. You actually upload the data in your vector database. Even for the vector embedding, there are different tools that you can use. And now you do the prompt engineering. You can develop your own system. It is not that difficult. Okay.
Yes, sir. So there is one last question. How to make use of all of us AI and prompt engineering towards an educational researcher to upgrade our data analysis and research project?
Wow, this is what I have already mentioned. The first thing what you need to learn, the first thing that you need to learn is the vector database, how to use vector database. Okay, that is the first thing that you need to learn. Okay, now from the vector database, you will learn how to do the vector embedding. Fine. Now, what you can do, you can take your website, the website of your institute. What we actually search over there, there are a lot of things we need to click, and then only we are getting the desired document. Okay, so now for that, what happened? It takes lot of time for the person. Now you embed your website using vector embedding. Once you embed using vector embedding, what will happen? Now you go for the different queries that the student can ask. Not only the student, the other person can ask. Okay, so with that you train your model. Now over the, based on the query that is coming, you upgrade your index. So for that reason, if there is any admission notice, the student do not need to search to the, go to the find the admission notice tab. Once they are talking about new admission notice, automatically the last few notice will automatically come. You can do it fine tune. How? For the notice, the date is given in the content. You need to retrieve the data and data, I'm sorry, that particular date. So you can say that show me the student may ask the different admission notice from 15th of April. So if the student will not go to the website, to the particular menu of the website to search that thing, they will give this thing in the chatbot. Your system has the data about the every notice date. Fine. So based on that, they can search the data. Okay, and your system, that means your LLM, from that you will retrieve the query and present that to the user in a presentable format. This is the way how we actually work.
Thank you, sir. There is no more question in my bag. So I just want to share my screen. Thank you, sir, for your valuable speech. We have got a number of feedbacks. So our chat box is quite overloaded. It's an excellent talk you have given. Thank you from all of us from the Department of Computer Science, Sister Nivedita University, India. So thank you all the participants. I'm requesting all of you to kindly give your attendance, and the assignment link will be given to the group. Thank you all of you. So same time next day again we will meet from 3 p.m. and tomorrow we are also having the final assessment after the session. Thank you. Thank you all of you. So I'm the ending the meeting here.